Welcome everybody. This is an application question. So this will benefit students studying cosine rule greatly. And it is imperative to mention here that without cosine rule or cosine law, there is no maritime navigation. So having mentioned you that is all important information, let me give you this question. There is a boat. So let me start like this. A boat leaves the port and travels a distance of say 10 miles and then takes a 20-degree angle, or I would say 20-degree turn, and then travels 8 miles. Then again it turns 20 degrees and travels 22 miles. Find the distance of the boat from the port. So it's a lovely question. Now for this question we would have to draw the figure. So let me probably I will use this space. So let me take this to be as the port. So from here the boat is actually leaving and traveling say 10 miles, right? Now from here it is taking a 20-degree turn. Okay, so this is the straight line. So from here there is a 20-degree turn. So let me take this as the 20-degree turn, and then it heads or travels 8 miles. So let me just put the 8 miles over here. 8 miles. So the boat is actually moving in this direction. Now from here the boat is heading in this direction, but suddenly what does it do? From here it takes a 20-degree turn. So from here let me put this 20 degree over here, and then it is moving. How much miles it is traveling? It's traveling 22 miles. So from here it's traveling 22 miles. So I will put it over here, and we are expected to find this distance. Okay, now this question we need to handle it with little bit care. So this is the direction of the boat. Let me draw the boat. So this is the boat, right? And you have the sea, waves in the sea. Okay, so we are expected to extract this distance, the entire distance, but I don't want to draw the line now as of now. Now there are a few things we need to know. Let me take this point as P, A, B, and say C. Okay. Now foremost, what I'm going to do is I am going to be finding this distance. So let me just draw the straight line. So the boat is actually moving out in this fashion. So this is going to be my straight line. So suddenly there is a 20-degree turn. Okay, now this entire angle from, if I were to take this point as O, this entire angle is 180 degree. So from 180 I subtract 20, I'm going to get 160. So this is going to be 160. Okay, so now let me find out this distance. What is this distance going to be? So I want to know what is PB. So by cosine rule, what do we know from cosine rule? I know that PB squared is equal to AP squared plus AB squared negative 2 times AP times AB times cos 160, right? So AP squared is 10 squared, AB squared is 8 squared, 2 times 10 times 8 times cos 160. This is 164 minus 20 160 times cos 160. This is 164 minus 160 cos 160. Okay, this is cos 160. This is going to be negative 0.94. So 0.94 multiplied with 160, and this negative will become positive. So 150.4 with 164. So you add 164, what do you get? You are getting 314.4. This is, what is this? This is PB squared, right? This distance. PB squared. So PB is equal to root of 314.4. So if I were to take the square root of 314.4, that is going to give me approximately 17.73 miles. Now you might be wondering, why did I get that? Now there is a reason for that. So when it reaches the station B, the distance of the boat from the port is 17.73 miles. Okay, let me have that in one corner. Now my next objective is, actually I need to get this angle. Okay, I need to know what is this angle. Now let me also use some demonstration via the figure. Okay, so now this is actually a 20-degree diversion, right? 20-degree turn. Now from here he takes 20-degree turn, so that would mean from the straight line there is a 40-degree diversion, right? So this is the straight line. So from the straight line there is a 40-degree diversion. So we need to exactly get this angle. So how are we going to get that angle? Can you pause the video and calculate and let me know? So let me show you that. I hope you have got it. Now what I'm going to do is, I'm going to stretch this straight line, that is the distance traveled by the boat upon taking a 20-degree diversion. So if I were to extend this, this is going to be the line, the straight line that the boat is supposed to have traveled, but it did not travel in this direction. Instead it takes a 20-degree diversion. Now this 20-degree, if I were to complete this with the line which is in the initial position, because the boat was heading in this direction and then it takes a 20 degree. This is going to be 90 degrees, the straight line, right? Now you have a 20 degree diversion here, and then there is again a 20 degree diversion here, right? So from the initial line PO or OP, there is a 40 degree diversion now, right? Now if I were to stretch this line, say this is going to be 180 degree. So from 180, if I were to take away this 20 and 20, I would get this to be as 180 minus 40 is equal to 140. So this is going to be 140, but I don't want this. I want to get this entire angle. I want to get this entire angle, right? So this is required. This is what is required. So this angle is required. So for that, I will have to know what is this. This angle has to be got. So how are we going to get this angle? Because once I get this angle, I can add this quantity with 140, and that would give me the entire angle. So we need to get that. So how are we going to do that? Okay, so we need to get this angle. So what I'm going to do is I'm just going to drop a perpendicular from B to O. Now there are many ways to get the angle, but I am just utilizing this technique. So you drop a perpendicular, and then clearly you know this is going to be 90 degrees, right? This is 90 degrees, this is 20, so 90 plus 20 is 110. So from 180 you subtract 110, you get 70. So this angle is 70. This angle is 70. This angle is 90. So 70 plus 90, this entire angle is 40, right? So you have 160, 200 degrees here. So this entire angle, this entire distance which we are talking about, this is going to be 200 degrees, right? So this is 200 degrees. Now the total circle is 360, so you subtract 200, you get 160. So this distance, this entire distance is, that arc is 160 degrees. Now what I want to do is, from 160 I want to take away this angle. If I take away this angle, then I would get this one. From 160, if I were to take away this one, then I would be left with the required angle. This angle I would have already got. So my main important objective now is to calculate this angle. So how are we going to calculate? Now I already know this distance, 17.73. So what we will do is, we will utilize that fact. We will utilize cosine rule again. Probably I will do it in this space over here. So I know this length, and I need to get this angle, and I also know this length, right? So this is the unknown, or I would say this angle is required. So let us take this as alpha. So what I will do is, I will take the distance PB squared plus AB squared minus 2 times PB times AB into cos alpha, right? Let me take this angle as alpha, cos alpha. So this is equal to this AP squared. So AP squared is 10 squared, PB squared is 17.7. I'm taking it as 17.7 whole squared plus AP squared is 8 squared minus 2 times 17.7 into 8 into cos alpha. So this is 100 and 17.7. So what is that? 17.7. You need to get the square of that. So that is 313.29. 8 squared is 64. So this is 17.7 multiplied with 8 multiplied with 2. So that's going to be 283.2 times cos alpha. So I will add these two things. So that's going to be 77329 minus 283.2 times cos of alpha. This is 100 degrees. So move these things like this. 283.2 times cos alpha is equal to 377.29 minus 100. This is going to be 277.29 divided by 283.2. This is cos alpha. So 277.29 divided by 283.2. So this is 0.979. This is equal to cos alpha. So alpha is equal to cos inverse of 0.979. So press the shift. I will press the shift. This is cos inverse. Cos inverse of 0.979. So that is giving me alpha to be 100. I would say 11.76 degrees. So this is the value of alpha. Okay, so this alpha is got. Alpha is equal to 11.76 degrees. So as I mentioned to you, I need this entire angle. So from 160, I subtract 11.76. So what is that going to give me? So 160 minus 11.76. 148.24. So this is the angle 140. This angle is 148.24. So I know this distance 22 miles, and I know this this entire length 17.73 miles, and I know the angle between that these two. So now I can get the distance of the boat from the port. Okay, this distance can easily be got. This is the objective of this question. So let me get this as P and final destination D, PD. So if I were to use the cosine rule again, PD squared is equal to BD squared, this distance, plus PB squared minus 2 times BD times PB times cos of the angle between them, between BD and BP. So that angle is got to be as 148 cos of 148.24. So BD squared is 22 miles squared plus PB squared is got to be a 17.7 squared, right? So BD squared plus PB squared, 17.7 whole squared negative 2 times 22 times 17.7 times cos of 148.24. So 22 squared 484 plus 17.7 squared, that is 313.29. so this is going to be 22 times 2 multiplied with 17.7, so that is 778.8 times cos of 148.24. so this is required, PD squared is required. So you add these two things, so 484 plus 313.29, that is 797.29 minus 778.8. Cos, get the value for cos. Cos of 148.24. That is giving me negative 0.85. I'll take it like that. So 0.85 multiplied with 778.8, that is going to give me this positive 661.98 added with 797.29. so you add 797.29, so that is giving me 1459.27. this is my, what is that, PD squared. So this is PD squared, so PD is equal to square root of 1459.27. so I take the square root of 1459.27. so that is giving me approximately 38.20 miles. So this is my PD. So from port to the destination B, 17.73. Now again from destination B it goes to destination, or I would say from station B it moves to the destination or station D. So the total distance is, in other words, from the port is 38.20 miles. Now why do we need to calculate all of this? Now this is in, I would say, the distance is little bit, or I would say it's too much minuscule compared to the ocean travels that ships, that cruises and oil tankers they travel, right? Now this technique is very much required, or very much important. Why? In case this breaks down, something happens to this boat here over here, right? There is a short circuit or some electrical surcharge takes place and the entire power gets down, or there is some, some level of discrepancies or some distortion takes place to the boat, in the boat, and the boat does not move. The boat is just there and they have anchored the boat, or the boat is just floating there. Now you need to tow the boat. Now to bring the boat back to the port, this distance gives an idea how exactly this operation can be carried out. Now this, as I mentioned to you, this is minuscule. 38.20 miles is minuscule, but usually this is not going to be 38.20 miles in the real-time scenario. It can be 3,820 miles or 13,820 miles, because ocean is very, very vast. So having the ability to obtain this calculation, it gives greater insights with regard to the rescue mission that has to be carried out, or even if they have to go here to give provisions and so on and so forth. Now this is a beautiful question. Now what I wish to do is, I would like to give you another link how exactly we can code this situation. So check that video out, it will enhance your capability. Thank you, students. Until we meet again, enjoy your day.